Hi everyone, I'm Suf and I'm excited you are here for our data science series. Today we are starting with NumPy on day 1. Whether you are new to data science or want to get better, this series is for you. In my last video, I mentioned we will cover three important tools: NumPy, Pandas, and Matplotlib. We will go through each one step by step, starting with the basic and moving to more advanced stuff. Let's dive into NumPy basics together and enjoy the journey. What is NumPy? NumPy, numerical Python, is a fundamental library for numerical and scientific computing in Python. It provides support for large multidimensional arrays and matrices, along with a rich collections of high-level mathematical functions to operate on these arrays. Then, why NumPy in data science? NumPy is essential for data science for several key reasons. It provides a powerful, flexible, and efficient toolkit for numerical computation, which forms the backbone of many data science operations. Overall, NumPy is indispensable for data science due to its efficiency, flexibility, and the rich set of features it offers for numerical computations. Whether you are performing a basic statistical analysis, manipulating and cleaning data, or integrating with other data science libraries, NumPy provides the foundational tools needed to handle data effectively. Open up your browser and search for Colab notebook like this. Then click the first link and click for the new notebook like this. We will be using this Google Colab, which is a free cloud-based Jupyter notebook environment. It allows you to write and execute Python code in your browser, make it an excellent tool for learning and experimenting. And Google Colab supports rich text code execution and even visualization libraries, making them highly versatile for data science projects. First, let's install the NumPy. If you are using Python IDE, then open up your terminal or command prompt and type pip install NumPy to install the NumPy library. In Google Colab, the NumPy comes with pre-installed. This means you can use it directly in your notebook without any additional setups. Let's import the NumPy library by typing the import keyword, then followed by the NumPy, and let's configure this NumPy as NP like this. First, let's talk about one-dimensional array. A one-dimensional array is essentially a list of numbers. Think of it as a single row or a single column of data. Then, what is array? An array is a data structure that can hold a collection of elements or items. Unlike a list, which can hold items of different data types, an array typically contains elements of the same data type. Arrays are particularly useful for numerical computations, are often used in scientific computation and data analysis. Well, let me add a new code cell, and inside it I'm going to create a variable array underscore 1d, then equal to numpy, which is np dot array function with a set of parentheses. Inside the parentheses you have to add a set of square bracket. Inside this square bracket add items, for example 1 comma 2 comma 3 comma 4 and 5. This line creates a simple one-dimensional array with elements from 1 to 5. It's like a basic list but with superpowers. Well, let's see the difference of list and array. The first one is data type flexibility. List can store elements of different data types within the same list, but arrays typically store elements of the same data type, ensuring unanimity throughout the arrays. Then, memory efficiency. Lists are generally less memory efficient compared to arrays, especially when storing large amount of numerical data. But arrays are more efficient, memory efficient due to their homogeneous data type, which allows for more compact storage. Then the last one is the performance. Lists provide flexibility and ease of use but may be slower for numerical operation due to their dynamic nature and type checking. But arrays offer faster access and operation, particularly for numerical computation, because they are implemented with contiguous memory storage and optimizes operations. Let's print this array 1D. Print with a set of parentheses inside it. Just put array 1D. Then just run this button and you will get a basic list from 1 to 5. Next, we have two-dimensional arrays, which are like a table or a matrix with the rows and columns. Each element in a two-dimensional array is identified by two indices, one for the rows and one for the columns. Let's create the two-dimensional array. I'm going to create a variable, say array underscore 2d equal to np.array with a set of parentheses. Inside it, add a square bracket, a set of square bracket. Inside the square bracket, add two more square brackets like this, and in each put the items or elements 1, 2, 3 and 4, 5, 6 like this. Notice how we use double square brackets to define rows within our 2D array. NumPy arrays are more efficient than Python lists, especially for large data sets, because they use less memory and provide fast operations. Next, let's look at some basic operation we can perform on NumPy arrays. We can add, subtract, multiply, and divide arrays just like with numbers. Let's see an example. Let's create a 1D array. Say my variable name is a equal to np.array function. Inside it, a set of square bracket. Let's put the value 10, 20, 30, 40. Okay. And let me create one more, b equal to np.array function. Inside it, a set of square brackets, say 1, 2, 3, 4, like this. Then let me add a code cell. Inside it, say add equal to a plus b, like this. Then let me print with a set of parentheses. Inside it, a double quotes, add equal to, like this, put comma, then the add variable, and let me run this. You will get 11, 22, 33 and 44. And same for the subtraction, same for the multiplication, and finally the division. As you can see, these operations are performed element-wise. NumPy also provides a wide range of mathematical functions. Let's explore some of them. To add up all the elements in the array, we use sum function. Let me create a variable whose name as say addup equal to np.sum function. Inside the parentheses, you have to put the array. Here my array variable name as a, like this. Then let me print the addup. You will get 10, which means 1 plus 2 3 and 3 plus 3 is 6 and 6 plus 4 is 10. To find the mean value of an array, you can use this mean function. Say my variable name as s equal to np.mean with a set of parentheses. Inside it, you have to put the array variable, array, say a, and let me run this, and then print with a set of parentheses inside it s, and you will get 2.5. Then standard deviation of an array. The standard deviation of an array can be calculated using the std function in NumPy. It measures the amount of variation or dispersions in a set of values. To do this, let me create a variable, say name as standard equal to np dot std with a set of parentheses. Inside it, you have to put the array. Say here my array is a, like this. Then let me print the standard standard. Then let me print this. You will get 1.1180 something, so on. To find the maximum value present in the array, you can use the max function. Here I'm going to create a variable m equal to np dot max with a set of parentheses inside it. Here my array variable a. Then let me print the m, and you will get the 4. And finally, to find the minimum value present in your array, you can use the min function. Say m equal to np dot min function with a set of parentheses inside it, the array a. Then let me print this, print m. You will get 1. NumPy makes it easy to perform these operations across entire arrays without the need of for loops. This is just a taste of what you can do with NumPy. In the coming days, we will explore more advanced topics and functionalities. That's it for day 1. Make sure to practice these basics and get comfortable with creating and manipulating arrays. If you have any question, drop them in the comment below. Don't forget to like, subscribe and hit the bell icon so you don't miss any updates. See you tomorrow for day 2, where we will dive into array indexing and slicing. Happy coding!